Hello, year fours! How are you? Are you well? Welcome to another problem of the week with me, your host, Mr. Morrissey. Now, in our last lesson, what was it we looked at again? It was the relationship between two kinds of numbers. That's right, fractions and decimals. We wondered what's the same about them, what's different about them. We looked at how you can convert from fractions to decimals, decimals to fractions. And I also set you what was, in my very humble opinion, a really cool investigation into recurring decimals. Remember those decimals that go on forever, but there's a pattern that repeats and you can create your own. You can find really, really cool ones. So I hope you had fun with that. In this lesson, we're going to carry on looking at that, so the relationship between fractions and decimals and how you convert between them. And we'll start with a bit of a recap of last week's amazing and fascinating learning. Let's begin. So we asked, what's the difference between decimals and fractions? And what would your answer be? Well, a decimal is a kind of a fraction. But it's a fraction only out of particular denominators. 10 might be a denominator, or 100 or 1,000 and so on. So a decimal is a kind of a fraction. We looked at this example. There's 100 squares in the whole grid. And then this section is 5 by 5. So that's 25 squares. As a fraction, how could you write that? Well, that's 25 squares out of 100. So that's 25 hundredths. And straight away you can write that as a decimal, can't you, using the place value chart. 0.25 is 25 hundredths. But we can simplify this fraction, 25 over 100. And one way of thinking about that is to realize that this square here, this section, well, it's one of 4 equal parts. You can imagine 4 of those squares making up the whole. So that's 1 part out of 4 in total. So 25 hundredths is a quarter, and we've already written it as a decimal, 0.25. So 0.25 as a fraction is 1 quarter as a decimal is 0.25. What can you see in this example? Well, maybe straight away you can see that that's half. That's half of the whole 100 grid. But what about as a decimal? A good way to think about it is to see that we have 5 rows, but it's out of 10 in total. So that's 5 out of 10, so 5 tenths. 5 tenths, that's a decimal, isn't it? 5 tenths, so 0.5 is a half, and a half is 0.5. For the recurring decimals investigation, I said you could just choose a fraction like 1 over 3, 1/3, or any fraction at all, and then to find out what that is as a decimal and then see if it recurs, just use this formula. Pop that into your calculator, so numerator divided by denominator. So you do 1 divided by 3, but I didn't explain why. So why can you use numerator divided by denominator to convert a fraction to a decimal? It always works, but why? Well, the bar model here might help us. What does 1/3 mean? 1/3 means you've taken the whole, like this whole rectangle, and you've split it up into 3 equal parts, and 1/3 would be one of those parts. But hang on a second, if you take a whole and you split it up into 3 equal parts, well, that's the same as dividing by 3. So to find a third, you can take a whole, that's 1, and split it into 3 equal parts divided by 3. And if you put that into your calculator, you'll get a response of 0.33333333, or you can put a dot above the 3, so 0.3 recurring. So hopefully that makes sense. What about 2/3? It's the same idea. 2/3 in our bar model would be 2 of those parts. But still, we've taken a whole and we've split it into 3 equal parts. So the first step is still 1 divided by 3, but this time we've got 2 of those parts, haven't we? We've got 2 lots of this. And by the associative law, you can actually do 2 times 1 first, which is 2. So that's the same as 2 divided by 3. So numerator divided by denominator. Did you find out what my super cool recurring decimal is for the fraction 1 over 81? So remember, you do 1 divided by 81. And it's best with a calculator, like I said, with a very long display so you can see lots of decimal places. And I'll leave that link again to a super long detailed online calculator again. But I'm going to show you, you get 0.012345 6 7. What do you think's next? No, it's 9. But then you go back to the beginning. 0 1 2 3 4 5 6 7. Skip 8 for some reason. 9, and it carries on. Isn't that cool? So you get all the single digits, but for some reason you skip 8. So I think that's a super cool recurring decimal. And there's loads of others, so you might carry on the investigation and find more amazing recurring decimals. So carrying on with the same idea a little bit more, you can see the fraction 3/10 there. How might you represent that? There's lots and lots of different ways. You could, of course, use a bar model. That's 3/10, isn't it? Because there are 10 equal parts in total, and then we've got 3 of them. So what would that be as a decimal if we're converting between the fraction 3/10 and the decimal? What would it be? Hopefully we know 3/10 actually is a decimal really already. We've got 3/10. 3 goes there, no ones and nothing else, so 0.3. So that's great, we know what 3/10 is as a decimal, but I did want to look at this a little bit more because we said earlier that you can convert any fraction to a decimal by doing what calculation? By dividing the numerator by the denominator. Now, what would that be here? What would the calculation be? 3 divided by 10. So would that work? Would that get us the correct decimal? And how would you work that out? 3 divided by 10. This time we're not using a calculator. In fact, a calculator is not the most efficient method here. You know how to divide by 10, don't you? And by 100 and 1,000, and how to multiply by 10 and 100 and 1,000 and so on. Really, there's no calculation to be done. There really isn't. All we use is our knowledge of our place value system, our base 10 decimal counting system. It tells us what to do, because if you look at our place value chart here, what do we notice? 10 divided by 10 equals 1, and 1 divided by 10 equals a tenth, and a tenth divided by 10 equals a hundredth, and so on. So to divide by 10, what do? You move the digits in what direction? It's to the right. Look at those arrows, to the right. How many places to the right? 1 place to the right. So to divide by 10, you move the digits 1 place to the right, because that's how our counting system is organized. Let's do it. 3, it's 3 ones. 3 divided by 10, we just move it 1 place to the right. I'm going to put it down there. And we do get 0.3. So again, numerator divided by denominator to find a fraction as a decimal. It always works. And then what about going the other way around? So converting from a decimal to a fraction. We can see the decimal there, 0.4. And actually, again, we're told the fraction. The fraction is there because it's 4 what? It's 4/10. That is a fraction, isn't it? So we've got our fraction. But when it comes to fractions, we do need to think, is this fraction written in its simplest form? Or is it an equivalent fraction? So 4/10. Can that be simplified? Now it can, but how would you simplify it? We could use the bar model. So we've got, that's 4/10, isn't it? But that's the same as It's 2 parts there out of 5 equal parts in total. So what fraction is that? It's 2/5. So 4/10 is the same as 2/5. Another way to do it is to compare the numerator and the denominator and think, is there a number that divides exactly into both of those? Is there a common factor? Ideally, can you find the highest common factor? So what factor is there of 4 and 10? What divides into 4 and 10? Well, 2 does. So 4 divided by 2 is 2. 10 divided by 2 is 5. So we get 2/5. That's the simplest form, but how do we know? Once again, ask yourself the question, is there a common factor of 2 and 5? Well, apart from 1, there isn't, and 1's no good. Dividing by 1, what does that do? It makes no difference. So you're not simplifying, you're not changing the fraction at all. There's no other common factor, so that's the simplest form of the fraction. So 0.4 as a fraction's 2/5. Some questions for you to do. The first one, complete that table. I really like that question because you're showing the same number in lots of different ways. And that really helps you understand the number very, very well. For the image, of course, there's lots of different possible answers. Number 2, what fractions and decimals are represented in these diagrams? Fractions and decimals. And the third one, how could you represent these decimals? There's lots and lots of different ways of representing them. So how many different ways can you find? 3 more problems there. Explaining, thinking, showing in different ways. Thinking about our understanding of fractions and decimals. And the answers. Some of my answers, I put some images here for 5/10 and 9/10. There's lots of other possibilities, of course. I put my fractions in their simplest forms, did you? And for the third one, there are so many different possibilities. You might have used a bar model like this, number line, tens frame, and you could discuss what's the same and what's different. And some possible answers to our problems. Well, sadly, it's time to say goodbye again as it is the end of the lesson. But don't fret, I will see you again soon for some more maths. And in the meantime, you can always carry on with the amazing recurring decimals investigation. No matter how many you've found, there are always more to discover. So have fun if you do choose to carry on with that. Take care of yourself, and I'll see you soon.